Hi, this is Harish here. Welcome to DB2 LUW Tips and Tricks Part 6 video tutorial. In this video, I'm going to talk about Event Monitor for Change History, or I would just like to call it as Simplified Audit feature. So it's not going to be very extensive audit feature like you have the DB2 audit command, which kind of implements a very elaborate, detailed, extensive audit feature functionality. But this one will really help you. We can call it as like a simplified audit feature, so at least we can understand what kind of specific changes that are occurring in the database. So there are certain specific things specific events which we can monitor through this change history event monitor. Okay, now what this change history event monitor does: tracking of changes to the database through event monitor. Is the same traditional event monitoring technique that is used, no new commands or something like that. So you can see the statement: create event monitor name for, now here's the keyword, change history, where event in all, write to table auto start. So when you say auto start, manual start, it's so typical of any event monitor. Whether when you are deactivating and activating the database again, that time this auto start will enable the event monitor to kick in by itself. Okay, and write to table, so there is no write to file, it's going to write to a table, so you don't need to format the event monitor output and all. Directly SQL based output is there, which is very flexible and powerful for computing. And the change history where event in all, that is the clause that makes the difference for this event monitor. So it tells the event monitor to track the changes and keep it in a history table. Now what kind of events? So we have declared event in all, which means all events. So when I say all, it's not like a universal all. There are some type of events this event monitor will capture. The type of events that it is going to capture is configuration changes, DDL changes, and utilities. And all the event related tables are automatically created, so we need not create them explicitly, it will get created automatically. And when we say configuration changes, apart from these three types of events, there are also another couple of events. Like for a transaction also, when a transaction commits or rollbacks, that is also considered as an event. And when a event monitor is getting started, that is also considered as an event. So those things I am not discussing in detail, but these three we'll look at in detail, because these are configuration changes, DDL changes, and utilities. So when I say configuration changes, it can be DBCFG, which is the database configuration file, or DBMCFG, which is the instance configuration file, or regvar, which means the registry variables. So all these three kinds of changes, whatever the configuration changes that are happening in the database or in the instance or through registry variables, can be tracked via this event monitor through the parameters. Like when I say event in, I can either say DBMCFG or DBCFG or regvar, or I can give a single keyword CFG all for tracking all the changes. Instead of saying DBCFG, DBMCFG, regvar, I can say it is in a single word CFG all. Similarly for DDL changes, the DDL all is for all DDL changes. DDL data means creation of tables, creation of indexes, etc., dropping of table, altering of table, etc. DDL SQL means creation of stored procedures, creation of triggers, UDFs, functions, packages, etc. DDL federated means creation of nicknames and all the federated related objects and configurations. So those kind of DDL statements will be captured. XML means XQuery and XML related operations. WLM, workload manager related, create workload, alter workload statements. DDL storage means any changes to the table spaces, like creation of containers, addition of containers, creation of new table spaces, altering the database storage paths, those things and all will come under DDL storage. DDL security, the grant and revoke permissions for your specific tables, those things are there. DDL monitor means if you are creating event monitors for statements or transactions or any other thing, those create event monitor statements will also be captured. Okay, now utilities, there is a single keyword util all for all the utilities. Otherwise you can use the specific utilities that you want to keep track of. Load utility. Move table is for the admin move table procedure, the online move table, which is there in 9.7.4 newly introduced. and reorg utility, restore utility, roll forward, backup, RUNSTATS, all these things can be tracked, like when that particular utility was invoked, who invoked it, what are all the details, like if you take RUNSTATS, where the RUNSTATS, like on which schema, on which table it was run, and with what additional classes, right, like the detailed indexes or detailed indexes class on all columns or on specific columns. The exact RUNSTATS statement also we can get it. So those are the type of events that this particular event monitor will capture, and this functionality is applicable available version 10 and above. And also when you look at like backup or restore or roll forward, only online based versions are available. Like there is no offline backup which this event monitor can track, because the database itself will be down, right, it's be in a deactivated state. So only online backup is available, and you need not track all the events. Like we have given here event in all, right, you can even specifically tell what are all the events that you want to capture. Okay, like look at this, we have given here where event in RUNSTATS DDL all, which means all the DDL related events plus not util all, we are not tracking all the utilities but only RUNSTATS, that's also possible. And when you can define your own tables as well. See, if you don't, event table will be created automatically if not specified. Look at the second one here, create event monitor for change history RUNSTATS DDL all, write to table. So what are all the relevant applicable tables that needs to be created? This is the event monitor itself will create it for you. Otherwise you can also specify, but when you specify, the type of event and the list of tables should match. Something like, see here we are saying CFG all, which means you have to give one table for the change summary, one table for DBDBM CFG, one table for registry variable changes. So for all these 3 tables you have to define. You cannot just ignore regvar table. So what will happen if you ignore? It's not going to error or something like that. There won't be any errors, but it will just be like you will not know what that change is. See, the change summary table will only tell you a registry variable was changed. What variable was changed, what is the old value, what is the new value, it will not have. For that you have to go to this registry variable table. Hence the type of events and the list of tables should match, otherwise you will be having missing information. Drop event monitor will not drop events table. So when you drop the event monitor, you have to explicitly drop the tables that you have created. Now let's look at few examples and try to understand this in a better way. Okay, so here I am just connecting to database. I am creating an event monitor. Change history is the event monitor name. For change history is the keyword, where event in all. So I am just using the all based parameter. So I am tracking all events. Write to table, auto start, then connect reset, and then activate DB. Again I am connecting to the test DB. I am listing the tables what are all it got created. Okay. Connecting, the create event monitor is successful, the connect reset is successful, the activate DB is successful, the connect to test is successful, list table. So it has created so many tables, right? So there is grouping in here. The change summary table is your main table, and see, every table will have this appended to the table name _chg_history. That's our event monitor name. Table name concatenated with the event monitor name. So the change summary is the base table, then which will just say at high level, okay, see, this particular user, this particular application, this particular change has occurred, and what is the timestamp that the change occurred. That's all it will tell. It won't get into the details. So if you are to get into the details based on the change, so if the change was a DBDBM CFG change, then from that event ID you have to map it to that appropriate table. So if it was a DBDBM CFG change, you have to come to the DBDBM CFG table change history and locate that particular event ID and find out what particular parameter, what is the old value, what is the new value that got changed. Similarly for DDLs. Similarly for utilities. Utilities, there are 4 tables actually, and similarly there is one for registry variables. Now why utility is having 4 tables? For the event the utility start, like when you just start the load utility, that is considered as an event. When the utility gets stopped, that is considered as an event, so it will stop. And util location, like say if you're using a load utility, then there is a del file or IXF file, right, from which you have to load the data. So that is util location. That kind of detail you will find there. And util phase, normally let's say if you are using load, then there will be this different phases that is going into, right. There is a build phase, there is a shadow copy phase, then there is a index rebuild phase, then there is a delete phase if you are using load replace. So those different kinds of phases of the operation, right. So that is the phase table. So there is a utility start table, utility stop table, which will give you when the utility got started or stopped, like when your backup got started or when your backup got stopped, and what are the different phases of the backup in the internal phases, and where is the location of the backup. So for utilities there are 4 tables. For regware there is only 1 table. Now we'll just look at this table I have just populated this with some sample data. I'll just show it to you how this works out. So this is one history underscore data.out. Okay, so what this table is containing is just like this: select star from the whatever the history tables that we have created, right. I'm just doing select star from all those things, and for the first 2 tables alone I am just selecting few columns. I don't want to give all the columns. So okay, now we will look at the history data.out. So this is the change history table. So this table is going to it's going to give me the application ID. It's truncated here. I have used substr function and truncated the output. You can get the full this thing. This is the one which is coming with the list applications command. So the application ID, the application handle, the application name, the event ID, the event timestamp, and what kind of event occurred, and under what session authentication ID it occurred. See, under which authorization ID it occurred. So here it will say these are all the different types of events. So which means registry values are changed, DBM values are changed, DBCFG values are changed, right. But let's look at DBCFG values. The event let's look at DBM CFG values. So it says that DBM instance value has changed by event ID 28. So I have to look into that appropriate table, which is the DBM CFG change history table. The sample output is here again. So if you look at this event ID 28, see, this is the event ID 28. So it says there are multiple entries here. So for all the database parameter, okay, the exact parameter name, what is the old value, what is the new value, what is the collection type. If it is I, means probably it is initialization process, like that we can, or the instance itself has done the change. Okay, deferred means, so you see sometimes the parameter, if you use the update command and update DBCFG, update DBMCFG, it won't immediately get applied. You need a database restart or you need a instance restart. So then it deferred will be Y. So in this case, in our sample, the deferred is not Y. It's immediately applied. So it is actually more like an initialization process. Okay, so here you can see it is DBCFG values or DBMCFG values, which means it is just initialization process, because you will find here the old and new values, there is no change here actually. So it's just part of initialization process. Okay, now let's look at one more sample file. See here, there are those old 4 records are already there. And apart from that, if you find here, see here DB2 STMM has come into picture. So this, the self-tuning memory feature of the DB2, this has come in and it has modified few parameters in DBCFG, right, and the event ID is 30. Now what it has modified, for that I have to look into DBM CFG change history table with event ID 30, so which is here actually, event ID 30. Let's look at event ID 30. This is event ID 30. See, it has changed the lock list parameter from the old value 8352 to new value 7776. So the type became, see, the instantiation type is U, which means user has changed it, and it is not deferred, it's immediately applied. So this parameter was changed by user. Who is that user? It's actually not a user like an end user, it's a system internal process only that changed it, right? So what is that 30? Who is that user? See, the application is DB2 STMM, which means that the STMM is an internal kind of application, so that only it has changed the DBCFG parameter value. So this is how you have to correlate. So like this, so when you find DBCFG, which means there is some kind of change. When you say DBCFG values, it might be due to some initialization that it has occurred. Okay, so you have to clearly look for this. Now look for this 34 DBCFG, it has changed. 34, what it has changed? See, the database memory itself is changed from 38,784 to 38,650. So the database memory parameter value is changed by the STMM here. Okay, so this is how it works. Now we will do few more examples and we'll test it out. That way it is more clear for us. So let's change the log timeout parameter. Okay, copy this. So I'm just first trying to get what my log timeout parameter value is. It's 30. Okay, now I'm going to change that 30 to -1. Okay, now let's do one thing. Before I make the change, what is my values here? So before I make the change, I am querying the DB-DBM-CFG parameter table for the value log timeout. Okay, copy this. See, before I make the change, the old value is also 30, the current value is also 30. It is as part of the database initialization process DB CFG values, which means it's part of initialization process. The database got initialized with this setting only. Okay, 30 and 30. Now I am going to change this to -1. Copy this, come here, paste it. Now it gives me a warning message saying that this parameter will not be immediately applied. I have to reactivate the database, right? Fine. Now let's look at this value. I am looking at the change summary history table. See, it has said to me at this timestamp, look at the date, 18/18/44. See, see 18/18/19. So just before this thing we did this change, right? We updated DBCFG parameter, right? So that it is showing here. Okay, now let's look at the other table, which is DB-DBM-CFG table for log timeout. What exactly we changed, that we need to show, right? It needs to show. Okay, look here, log timeout 30 was the initial old value, new value is -1, and it was done by user. It's deferred, which means it has not still applied it. Okay, and look at the keyword here, DBCFG. So when you find the keyword DBCFG, which means user has done that change, not the system or part of any initialization process. Okay, now we will kind of reactivate the database. Okay, so for that I need to connect reset. So I'll connect reset, I'll deactivate the database, I'll activate the database again. Okay, done. Now I'll go to the other terminal, I'll connect to the database and I'll list the timeout value. See, earlier there were only 2 records, now there are 3 records because we deactivated and activated it, right? So now what happens, the log timeout is -1 initialization process DBCFG values. So we changed it to, from 30 we changed it to -1. It was a deferred activity. Once we deactivated and activated back, it got applied. So when it is, so when you see here DBCFG values, it can be because of the initialization process it is applying. When you see DBCFG, it indicates that some change has occurred and whether the change is there or not, applied or not, you can find it from the deferred. And when you deactivate and reactivate, one more record got added saying that it has reapplied the change. Okay, now one more tricky thing we'll do, we'll completely we'll connect reset. Okay, we'll go to the other terminal, we'll deactivate the database. Okay, now you do the change. See, this is the tricky part. Now the database, it's not active. Event monitor, obviously database itself is not active, so event monitor will not be active, right? So but then I am again changing the log timeout parameter to 45. Update got successful. Now I am activating the database again. Okay, now I here connect to the table and I'll look at the log timeout in the DBM CFG change history file. So now you will have 4 records here. So even when the event monitor was not active, right, the event got captured. It is because of that initialization process, right? When the database becomes active again, it's going to apply the deferred values. So that's why it is going to say here DBCFG values. So the DBCFG values is either part of initialization or it can be based on the nature of change, right? Sometimes it can, the instance parameters or the instance values or the DB parameter values will not be applied immediately. It will be a deferred one. So that time, for once it will write the value as DBCFG, and the next time when it initializes, it will initialize with DBCFG values. If the event monitor itself is not active, okay, then also the change is captured and it is written as DBCFG values, right? That is the key point here. Okay, that is the key learning. That's the difference between the DBCFG and DBCFG values. Okay, DBCFG means user has changed it or the internal process has changed it, there will be value difference. When it is DBCFG values, it will be either the event monitor was inactive and it has applied it as part of the database activation, or it can be because of a simple database initialization process with the initial value and the current value being the same. It can be either of way. Okay, so the same applies to DBM CFG also. Like, see, this is the same parameter. I am just updating at an instance level. Util impact limitation parameter. I am just let us first get that parameter, what that value is, so that that change we can do. So DB2 get DBM CFG pipe grep -I util. So the util impact limitation is 15 only, so we'll try to change it to something like 10. Okay, this is the default value, so I'm just changing, it's now 15, I'm changing it to 10. Okay, so here it got immediately applied, right? Which means that if I come here and I'll run the query, so this time I am running with CFG name util impact limitation. Okay, copy this and execute it here. See, it will immediately tell util impact parameter old value 15, new value is 10. It is done by user. It's not a deferred, it got applied immediately. It doesn't require any instant restart and all, and it is DBM CFG parameter that got changed. It did not require any instance restart. That's the difference actually. Okay, and we'll try set this particular skip inserted. Okay, so let's first look at the initial value. It is actually off only, so I'll try to set it as on. Okay, okay, now I set it as on, but once I set it as on, if I go there, so this time I have to look for registry variable table, registry variable name as skip inserted. It's not there actually, that on change is not there. Okay, because it requires an instance restart. Okay, it's not kind of effective. Okay, so for that, for instance restart, I'll say DB2 connect reset, then deactivate the database, and DB2 stop. I am completely stopping the instance itself. I have to start the database now. Start the instance, DB2 start, and then I have to activate the database, and then I can connect to the database, and I'll look for the skip inserted value. There were 3 records, now you should see 4 records. Yes, see, it has, the event ID is 2, the value skip inserted value is on, the old value is off, the new value is on, and it is part of initialization process because it says regvar values. So if we can find some kind of registry variable which will get applied immediately, then you will find that it is, instead of regvar values, it will put as regvar. So I was not able to find any value like that. Okay, and let's do few more things. Okay, see here I am creating a table A, table B, then I am creating index on table B, then I am altering a table. Okay, and I am selecting some records from table B, and I am inserting some records into table A and creating a table space, and I am granting DB2 access to a particular user, and I am executing a stored procedure. I am creating a stored procedure. So many activities I am doing here. So the create table got successful, index table, select statement, nothing is there. The insert did not go through well. Okay, and the stored procedure also got compiled correctly. The insert did not go through because of the it's missing a reorg. So DB2 reorg table A. So I'm just doing a reorg table. Now the insert should be successful. Okay, the insert is got all successful. Now let us look at, see, these are all some DDL changes we have made, right? So are all these captured? So where it will be captured? In DDL statement exec change history table. So I'm just querying that table now. So look at all the events that we created are all captured. See, the create table, table A, table B, create index, then alter table, then my TBSP, create table space, my TBSP, then this security related grant DB2, then the create procedure, everything got created. The insert statement and select statement won't come because those were DML statements. So DML statements won't be tracked, only DDL statements will be tracked. And you can look at the category also. When it says data, it means create table or create index, like that. When it says storage, it has to do with table spaces. When it says security, the permissions. And when it says SQL, it is like create procedure, right? These things we saw when, okay, so this is how it is capturing. Okay, now let's do the utilities things. Okay, let's run a load and let's run a RUNSTATS. Okay, so I'm just running a load and a RUNSTATS. I'm loading table B with some data and I'm running RUNSTATS on table B. So the data got loaded, the RUNSTATS also got completed. So for utilities, there are 4 tables we discussed, right? One is utility start, another one is utility stop, another one is utility location, another one is utility phase. So we'll look at all those records. So I'll just run through everything. Okay, copy everything, paste. Okay, so if you look at this first thing, so this will be the utility start, right? So the utility invoker is user, the event ID is 2020, the event timestamp is this, utility start. So on table A one reorg has been done. So utility detail will tell you exactly we did a reorg on table A, right, to insert the data, so that it is showing. And 28 is for table B. Schema name is DB2 INST1. It's a table level operation and it's a load operation, and the load is I, which means the load is insert type of load, and this is the load. Okay, and the next activity is 31. On table B there is a RUNSTATS that is run, and it will even give the exact query, the exact RUNSTATS command actually. Okay, we have truncated the output, that's why it's not showing. If you can just I have used the substr here function to just demonstrate all the columns. So the exact RUNSTATS statement is also given here. This is utility start, then there will be utility stop. Okay, so the next thing is utility stop. So this 20 utility, which is a reorg, right, there will be a start event ID here also. See here. So in the utility stop table you can look for the start event ID 20. For that the stop event ID is 21, and it has successfully stopped the reorg utility. And how will I say it's successfully stopped? The SQL state is 0. See here, it gives the SQL state of the load utility output operation. So if there is some reorg or some load or some RUNSTATS got failed, there will be some SQL state that will be there, right, that can be captured. What happened to the execution when it stopped, why it stopped also it is giving, whether it was a smooth stop or whether there were some errors associated with the stop. That also we can understand. And the next thing is utility location. So look at this here, this is very important. When we loaded the data, from which del file we loaded the data, even that is showing here. See, and what is the activity event ID associated with it? 28. So 28 is what event? 28 is a load on table B. So for loading on table B we have used the del file, from which place the path is given here in the utility location. And the phase, I think phase it is not showing, maybe it's not for load utility or maybe it's a bug, I am not sure, but maybe I am having very less data, like in a real time scenario you will have more data, it will distinctly get into those phases of operation. Or it might be for backup or something, some other utility might be using it, so we just need to check up on that. So this is how the utility stuff is going to work. Okay, this is how the change history event monitor is going to work. And you can also specifically give like this combination of activities. If you don't want, if you are not interested in all changes, you can specifically give the combination of activities and try to get the things done. Okay, so this is a very simple event monitor which you can utilize, and it is very useful and effective. No performance very drastic considerations that you have to make. So this is really good. Okay, and thank you for watching. Thank you for subscribing to DB2 LUW Academy channel. Thanks very much.